So this article is related to neural network assisted dynamic spectrum allocation in cognitive radio using MATLAB. So cognitive radio network, basically CRNNS short form, rely on efficient spectrum allocation, which is basically to optimize the utilization of wireless network. And in this article, we have just worked on the deep learning based approach for spectrum allocation in CRNS. A DL model basically predicts the primary user's activity using the historical spectrum sensing data. The model guides secondary users to select the channels balancing throughput and collision avoidance as well. So the simulation results shows the DL approach achieves a high prediction accuracy and improves the spectrum utilization. The proposed method outperforms the traditional schemes in throughput and collision rate matrices as well. So the single SU scenario is analyzed with the potential extension to multi-SU networks. If we talk about the performance, then the performance metrics include throughput, collision rate, and spectrum utilization, and which also ultimately this complete paper demonstrates the DL's potential for enhancing the cognitive radio spectrum management. So the abstract with the introduction. In the introduction, I have just explained to you how the PU spectrum occupancy map, and in the introduction, I have also explained very well uh, selected channel index over time, like how the channel free probability scores, how overall system performance, distribution of DL channel scores according to different multi-SU networks, and the primary user activity model is defined as on-off transition probability, and transition probability from off to on is 0.3 and from on to off should be 0.4. Okay, so next is background and motivation is that in the DL models can learn complex patterns in PU activity, enabling the proactive spectrum access. This paper basically proposes the DL-based approach for spectrum allocation in CRNS. So these are the system model and assumption system parameters used in the MATLAB for the simulation of the radio cognitive networks, and PU activity is modeled as a Markov chain with two states called on and off probabilities. Okay, so the deep learning based approach is defined that in the model is trained using a supervised learning approach with the goal of minimizing the prediction of error. The neural network architecture basically consists of multiple layers, including the convolutional and fully connected layers. The DL model is implemented using a deep learning framework such as TensorFlow or PyTorch. The training data basically is generated through the simulation using a PU activity model as a Markov chain. Here is a performance of evaluation based on the accuracy, throughput, collision rate, and the spectrum utilization. And then confusion matrix also provide us the actual, absent, and present actual PUs. Okay. So these are the problem statement. Then the mathematical approach is defined here, in which I have added the complete PU activity prediction and cooperative sensitivity equations, and according to on-off probabilities equations as well. So this is a methodology in which I have just explained like how the Markov chain model is applied in MATLAB and how the training dataset is using in the simulation to get the PU activity model, and how the results effectiveness of the approach in the improving of spectrum utilization and reducing the collision rates as well. Here is a MATLAB simulation according to the PU spectrum accuracy map, occupancy map. Okay, next one is basically the number of busy channel versus time, and next one is the DL prediction confusion matrix, and next one is SUSS outcomes and selected channel index over time and channel free probability scores, also the prediction correctness histogram and the overall system performance and the spectrum access distributed DL channel scores as well as the training progress. So then results and discussion with conclusion and references are added. Let me just provide you the DL spectrum output results in terms of MATLAB demonstrations. Total samples generated almost 29,940. It is taking some time because training deep neural network is used in it. So these are the training neural network according to 4890. See, the iterations are completed according to training iterations. Different approaches are declared here. So these are training progress is completed right now, and next is that we need to identify the overcome of next training smooth data. Okay, so just a second, let me finalize it and then I will tell you. This model is in running condition right now. It's finalized and then it will provide the output results accordingly. Okay. See, these are the output results accordingly, 10 figures. Distributed DL channel scores, spectrum access distribution, overall system performance, prediction correctness histogram, channel free probability scores, selected channel index over time, SUSS outcomes, DL prediction confusion matrix, number of busy channel versus time, PU, spectrum occupancy, fancy map as well. Okay. So if you need to ask anything, you just ask me. I will answer your questions. Thank you.
So this article is related to deep learning based spectrum allocation for cognitive radio networks. So let me explain to you. The system parameters are defined here, then the initialization of cognitive radio environment, primary user activity model, and all the Markov on off parameters, and then for loop for the prediction of on off loop accordingly, and then dataset generation. These are the loop for the dataset generation. Nested loop basically used for loop, and then total samples generated according to train and test as split with the random parameters. And these are the deep learning model according to the layers of fully connected layers, ReLU layers with the different parameters like 64, 32. These are the basically layer size of the layer. Okay. So next one is the option for the training options. These are max apertures and the shuffle every aperture verbose and false and plot training progress. This is a print command to print the in the command window like this code. When the code will execute until this uh, line, then it will print that training deep network completed. And next one is prediction of performance. These are the code for the prediction of performance. Spectrum access scheduler, and which contains the clean idle slot chosen and talent channel log accordingly. And these for loops for nested for loops used to get the training history of the hypothesis according to free probability. And next one is the performance matrices. These are the performance matrices and print the his commands as well. And next one is the results plot according to the PU spectrum occupancy, number of busy channels versus DL prediction confusion matrix, then SUSS outcomes, selected channel index over time, channel free probability scores, then the prediction correctness history as well. And these plot 8 is overall system performance, plot 9 is spectrum access distribution, and distribution DL channel scores as well. Okay. So if you need to ask anything, you just ask me. I will answer your questions. Thank you.